This is the Unit 5 Lesson 2 retrieval in our packet. It is on page 15. Okay, number 1, we're supposed to graph the equation and then determine if 2, 7 is a solution to the equation. Equation is y equals negative 2x plus 7. All right, let's start with graphing. And as always, that starts with us drawing in the x and y axis ourselves. Actually, that was some of my best work. Okay, this line starts at 7, so I'm going to count up from the x-axis. 1, 2, oh God. 1, 2, 3, 4, 5, 6, 7. Why do I never... I have glasses. Don't put them on. All right, the slope here is negative 2, so we're going to go down 2 over 1 to find the next point. Down 2 over 1, and let's do that just several times. Okay, there we go. Okay, now the next thing we're supposed to do is check to see if 2, 7 is a solution. I can already kind of tell that that's not a solution, but let's just check. I go over to 2 on the x-axis, 7 on the y-axis. This would be the point 2, 7. And that is clearly not on the line. So the answer is no, it's not a solution. In order to be a solution, it's got to be somewhere on the line, one of the points I just drew. Okay, number 2 says to find another coordinate that is a solution to the equation. So really we can pick any of these points, like this one right here. 2, 3. That would work. 3, 1. That would work. Up there at the top, 0, 7 would work. Any point that we graphed in number 1 works as a solution. Okay, last thing we have to do is graph the system of equations and find the point where they intersect. Verify that the point of the intersection is a solution for both equations. Okay, when I put in the x and y axis, I notice that this one has to start pretty low. Is this even gonna fit? Okay, I guess I'm gonna put the x-axis here and the y-axis here. I don't think this is gonna work very well, but we're gonna make do. I'm actually gonna start with this second equation. It's starting at negative 9, so there's negative 9. Now its slope is up 2 over 1, because remember 2 is the same as 2 over 1. So I'm gonna go up 2 over 1, and I'm just gonna do that many times because I'm gonna have to find an intersection. It's just better if I have a lot of points on here. Okay, that's plenty of points. In a somewhat straight, I mean, that's pretty good. That's pretty good. Okay, now for our second line. This one starts at positive 6. I don't think that's quite gonna fit on here. 1, 2, 3, 4, 5. Okay, right there. It's close. Okay, and this slope is negative 3, which is like negative 3 over 1. So I'm gonna be going down 3 over 1. And I'm just gonna do that a couple times. 1, 2, 3, 1. Hey, that looks like the intersection. Okay, let's draw that line. Okay, now we can get to the intersection. So that is at 1, 2, 3 on the x-axis, 1, 2, 3 on, negative 3 on the y-axis. So the point of intersection is 3, negative 3. Now they told us to verify that this is a solution for both equations. So what we have to do is plug it into each equation. So this y, I'm gonna put in negative 3 equals negative 3. Instead of x, I'm gonna plug in this 3. It's a lot of 3's. And then let's just see if this works out. This is negative 9 plus 6. Yes. Okay, cool. So it worked in the first equation. Now I'm going to plug it into the second one. Negative 3 equals 2 times 3. Yeah. Perfect. Okay, that's how you can make sure that your point of intersection is actually the solution for both equations. You just plug it into both equations and you should end up with something true, like 10 equals 10, or 1 equals 1, or 0 equals 0, or something like that. Okay,